Hi everyone, today we are going to solve the leetcode question to sum. So you are given array of integers nums and the integer target. Return indices of the two numbers such that they add up to target. You may assume that each input would have exact one solution and you may not use the same element twice. And you can return the answer in any order. So let's see the example. So you are given 2, 7, 11, 15 and target is 9 and the output is 0, 1 because index 0 plus index 1 equal 9. So that's why we need to return 0, 1. Yeah, this is a very simple question, but I think this question is good to understand how data structure can optimize the solution. So let me explain how to solve this question. Okay, so this is an input array, and I changed the order a little bit, and the target is 9. So to solve this question in the simplest way, we check all possible pairs one by one, and then find the target number. So let's say we are now 2, like a 2 plus 11, 2 plus 15, 2 plus 7, and so when we were 11, like 11 plus 2, 11 plus 15, 11 plus 7, but time complexity of the solution should be like a order of n square. That means if you get like 100 numbers as an input array, so in the worst case, you have to check 100 multiply 100, so 10,000. So that is a very time consuming. So how can we optimize the solution? Actually, we can solve this question with like a order of n. So to solve this question with linear order, we use hash table. So actually, I already drew down the hash. So left side is key, right side is value. And basically, I iterate through all numbers one by one. And every time, like there is a calculation, like a target minus current number. And then we need to find the answer in hash. And when we find the answer in hash, then return the current index and the index we already put the hash. So okay, so let's begin. So now we are index 0 and target is 9. So 9 minus 2 equals 7. So the 7 is the number we need so far. So find the 7 in hash, but there is no number in hash. In that case, add current number as a key and add current index as a value, so to 0. And then move next. So 11, so target is 9 again. 9 minus 11 is minus 2. So find the minus 2 in hash, but there is no minus 2 here. In the case, add current number as a key, 11, and the current index as a value, so 1. And then move next, and 15. So target is 9. Again, 9 minus 15 is minus 6. And I find the minus 6 in hash, but there is no minus 6. In the case, add 15 as a key, add current index 2 as a value. Then move next. So now we are 7. So 9 minus 7 is 2. And try to find 2 in hash. So we have 2 here. So in that case, return current index 0, 1, 2, 3, and 3. And index 0 here. So 3, 0. So that is the answer index. So in this case, 0, 3 is also fine. So because description said we can return like any order. So that is a basic idea to solve this question. and the time complexity is the order of n. So much better like a order of n square. So with that being said, let's jump into the code. Okay, so let's write the code. First of all, initialize hash, and then start looping. So we are taking the index in range and the length of nums input array. And then first of all, we need to calculate what number we need. So sub equal target minus current number. And then if the answer in hash, then return current index and the index we found in hash. So hash sub. If not the case, add current number as a key. So nums I, and add a current index as a value I. Yeah, actually that's it. So let me submit it. Yeah, this solution works. And I forgot to say space complexity. Space complexity of this solution should be order of n because we are using hash. So potentially we need to add all numbers to hash. So that's why order of n. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of two-sum. So for brute force solution, time complexity of algorithm to check all possible pairs is order of n square, and the space complexity is actually O1. And for hash solution, so time complexity is order of n. Space complexity is also order of n. So let's focus on only space complexity. Actually, brute force solution is better. But if we use the memory, we can improve the time complexity like drastically. So for the most case, I think order of n square is not acceptable. So anyway, so for hash solution, so step 1, so initialize empty hash. And step 2, start looping and calculate target minus current number and find the answer in hash. If we have the answer in hash, then return current index and answers index. If not, add current number as a key and current index as a value to hash. Yeah, actually that's it. And I hope this video helps you understand this question well. If you like it, please subscribe the channel and hit the like button or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, move zeros. So you are given integer array nums and move all 0 to the end of array while maintaining the relative order of the non-zero elements. So let's see the example. So you are given 0, 1, 0, 3, 12, and the output should be 1, 3, 12, 0, 0. So we need to move all 0 to the right, like this. And then also we need to keep the order of non-zero numbers, like 1, 3, 12. So that's why output should be like a 1, 3, 12. And the most important thing is that we must do this in place. So that means we cannot make a copy of the array. So let me explain how to solve this question. Okay, so I copy this input array from example 1, like 0, 1, 0, 3, 12. So first of all, I initialize left pointer with 0. So this left pointer is a location where we put the next non-zero number. So basically, I iterate through all numbers like one by one. And then when we find a non-zero number, just swap the current number with the number at the left pointer. So let's begin. So we are now index 0. This is the current number is 0. So we don't do anything, just move next. So now index is 1. So we find a non-zero number. In that case, swap current number and the number at left pointer. So swap like this. So index 0 should be 1, and index 1 should be 0. And then when we swap the numbers, just update the left pointer to next. And then move next. And check the current number. The number is 0, so we don't do anything. So move next. So we find a non-zero number. In the case, swap the numbers, like 3, and the current left is index 1, so 0. So swap the number like this. So index 1 should be 3, and index 3 should be 0. So by the way, index 2 is a 0. And then, so we swap the numbers, so update left number to next. And then keep going, so move next. So again, we find the non-zero number, 12. So in that case, swap the numbers. Like in the case, index 2 and index 4. So like this. So 12 is going to index 2. And index 2 going to index 4. And then move next, but there's no number, and stop looping. And then all we have to do is just return input array. So output should be 1, 3, 12, 0, 0. So we successfully all zeros to the right place. And then also we keep the order of non-zero numbers. Like so original input array is like 1, 3, 12. So 1, 3, 12. We keep the order of numbers. I think looks good. So that is the basic idea to solve this question. So with that being said, let's jump into the code. Okay, so let's write the code. Actually, it's not difficult. So first of all, initialize left pointer with 0, and then start looping, and taking index I in range, and the length of input array. And then, as I explained earlier, if current number is not 0, in that case, we need to swap. So how can we swap the numbers? So it's easy in Python. So we can write like this. So index I, so current number and the number at left pointer equal, and number at left pointer and current number. So we can write like this. And then when we swap the numbers, so update the left pointer to next, so left plus 1. So actually that's it. After that, just return input array. So let me submit it. Oh, so we got error. Sorry, typo, nums. So let me submit again. Yeah, so this solution works. So time complexity of this solution should be order of n, because I iterates all numbers like 1 by 1. And the space complexity is O1, because I don't use like extra memory. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of move zeros. Step 1, initialize left pointer with 0. Step 2, start looping, swap a number at left pointer and the current number. If the current number is non-zero, and move left pointer to next only when you swap the numbers. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, let's solve the leetcode problem, product of array except self. So you are given integer array nums, return the array answer such that answer index I is equal to the product of all elements of nums except nums index I. So let's see the example. So you are given 1, 2, 3, 4, and the output should be 24, 12, 8, 6. The reason why we should return this output is that, so let's say, so 24 is index 0. So in that case, we have to multiply all numbers except index 0. So which means we need to multiply 2 multiply 3 multiply 4, which means 24. And then for 12, 12 is index 1. So we need to multiply like 1 multiply 3 multiply 4, which is equal to 12. And for 8, except index 2. So 1 multiply 2 multiply 4 is equal to 8. And the last, 6. So 1 multiply 2 multiply 3 is 6. So you must write an algorithm that runs in ON time and without using the division operation. So let me explain how to solve this problem with a ON solution. Okay, so you are given the integer array 1, 2, 3, 4, and this is an output list initialized with 1. And I use like a left and a right to keep current number. So let's begin. So I think it's hard to manage which number we should multiply. So to simplify the question, I use two loop, and one is from left to last, and the other is right to head, except the number I should avoid, as I explained earlier. And so let's begin. So first of all, index I here, and we should avoid index 0. So we don't do anything. And then before that, before moving to next index, multiply this number to left number. So 1 multiply 1, which is 1, still 1. And then move to next index. After moving to the next index, first of all, multiply this number to this number, so which is 1. And then before moving to next index, so multiply current number to left, so which is 2. And then moving to next index. And then first of all, multiply left number to current number, which is 2. And so let me write down the index I already used. So index 1, I use just 0 index, and the index 2 is like a 0 and 1. So 0 and 1. And then before moving to next index, so I multiply current number to left, so which is 6. And then go to next index. And then first of all, multiply left number with 6. And then finish. And so this index already used like a 0, index 0, 1, 2. Okay. And then going back to from right side to head. And so first of all, index I, the number is 4. So we should avoid multiply this number to here. But before move back to the index 2, I multiply 4 to right number this time, so which is 4. And then move back to here. And then first of all, multiply right number to current index, so which is 4 multiply 2, which is 6, which is 8. And so index 4 is index 3, so I use index 3. And then before move back to previous index, so multiply current number to right number, so which is 12. And then move back to previous index. And then first of all, multiply right number to current number, so which is 12. So 12 that consists of the number at index 2 and 3. So
0, 2, 3 here. And then before move to previous index, multiply current index 2, which is a 24. And then move back to our previous index. And then after that, multiply right number to current number, which is a 24. So, and the 24 is consist of the numbers at index 1, 2, 3. So 1, 2, 3. Yeah, and actually finished. So the output list has like 24, 12, 8, 6, exact same this output list. So I think it works. And index I use, for example, at index 0 is like 1, 2, 3, except 0. And at index 1, 0, 2, 3, except 1. And at index 2, 0, 1, 3, except 2. And index 0, 1, 2, 3, and except, so I use index 0, 1, 2, except 3. So it looks fine. And I just use a to loop. So I think time complexity is order of n. So with that being said, let's jump into the code. Okay, let's begin. So first of all, I initialize the output list, like 1 multiply length of input array. So this program creates a list like 1, 1, 1, 1, and then set left, and I iterate through the input array from left to right. So to do that, in range and the length of nums, and then first of all update the output list. So output I update the output list with left number. Then before moving to next index, update the left number with current number. So multiply current number. So left multiply nums current number, and then finish this loop. Pretty simple. And then I use right. And then in this case, going back to from right side to left, so I mean last to head. So to do that, for loop is like length nums minus 1, minus 1, minus 1. And then same thing, first of all, update output list with right number. Then before move up to previous index, update the right number. So right multiply current number, and just return the output. Sorry, I typo. So output, and then submit again. Yeah, we got success. This is a step-by-step algorithm of product of array except self. Step 1, initialize output with list 1, multiply length of input array. Step 2, initialize the left number with 1, and start looping from left to right. Multiply the left number to a current number in output, and multiply a current number in input array to the left number. Step 3, initialize the right number with 1, and start looping from right to left. Multiply the right number to a current number in output, and multiply a current number in input array to the right number. Step 4, return output. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, top k frequent elements. So you are given integer array nums and the integer k, return the k most frequent elements. You may return the answer in any order. So let's see the example. So you are given 1, 1, 1, 2, 2, 3, and the k equal to, output is 1, 2, because we have 3, 1, and 2, 2, and 1, 3. And in this case, what is the most frequent elements? That's like 1 and 2. So that's why output is 1, 2. So yeah, this is a very simple question. So when I tried this question for the first time, I came up with a heap solution, and the time complexity of heap solution should be k log n. But um, I came up with also linear solution, so which is better time complexity. Okay, so let me explain with this example, like 1, 1, 50, 3, 3, 1, and the k equal 2. So to solve this question with linear order, first of all, I count each number and keep them into hash. So now let's say, how about 1? How many 1 do we have? We have 3. And how about 50? We have only 150. And how about 3? We have 2. Yeah, and then in the next operation, we create a two-dimensional array like this. And this index number is not only index number, but also frequent times to show up for each number from input array. And then in the next operation, I iterate through hash. And then I put each number into 2D array. But how can we put them into 2D array? So now we have frequent times to show up for each number. So let's say we have a 3, 1. In that case, I put 1 into index 3. So that's why 1 is here. And how about 50? We have only 150. So I put 50 into index 1 here. And how about 3? So we have a 2, 3. So that's why I put 3 into index 2. Looks good. And then after that, I iterate through 2D array from last to end because this question is a most frequent element. So that's why we need to iterate from last to end because index number is a frequent times to show up for each number. So, and then every time we find a number, I keep it to like a return value. And then the length of return value is equal to k. In that case, we should return the return value. So let's begin. At index 6, we don't have a number. At 5, we don't have a number. At index 4, we don't have a number. At index 3, we have a 1. So I put 1 here. And then, so return value is, length of return value is 1. So keep going. So at index 2, we find a 3. So I keep 3 to, so return value 3. Now length of return value is 2, so which is equal to k. So that's why in this case, we should return 1, 3 as a result value. So that is the basic idea to solve this question. Time complexity of this question is order of n, and the space complexity is also order of n. So with that being said, let's jump into the code. Okay, so let's write the code. First of all, initialize set. Okay, so let's write the code. First of all, initialize hash equal empty hash, and then start counting each number for n in nums, and the count current number equal 1 plus count.get. Try to find the current number. If we don't have initial default value is 0. And then after that, I create a two-dimensional array like this. Freq equal 4 underscore, we don't use number here, in range, and the length of nums plus 1. So this plus 1 is very important. So because index starts from 0 usually, so let's say input array is 1, 1, 1. So we have a 3, 1. So as I explained earlier, in this case, I put 1 into index 3. So in that case, we need like this 2D array, like this. So this is index 3. So that's why I can put 1 into index 3 like this. But if we don't have a +1, so 2D array is like this. So in that case, it's gonna be like out of bounds. So that's why we need to +1. And then after that, add each number into like a 2D array. So for n number and the count in count dot items, and then add a number to the array. So break count dot append and n. And then after that, I create like a result variable with empty array, and then start looping from last to end in the 2D array. So for I in range, length of freq -1, -1, and -1, and then for n in freq I, so there is a possibility that we have a multiple number in the same index. So that's why we need to another for loop here. And then so append current number, and then if length of result variable equal k, in that case just return result variable. I think that's it. So let me submit it. Yeah, looks good. This solution works. And let me write one more program. Actually, we can solve this question with one line. So how can we solve this question with one line? To do that, just return x for x, y in counter or counter, and nums dot most common and k. I think this program solved this question, so let me submit it. Yeah, this solution also works, but in my opinion, this is a very like a Python way. I'm not sure we can use this one-line solution for real interview, so you can ask the interviewer about that. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of top k frequent elements. Step 1, initialize hash and start counting each number in input array. Step 2, initialize 2D array and add each number in hash to 2D array by frequent time to show up for each number. Step 3, start iterating from last to first in 2D array. Every time we find a number, keep it as a result values. Step 4, when length of result values is equal to k, then return the result values. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question contains duplicate. So you are given integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So let's see the example. You are given like a 1, 2, 3, 1, and the output is true because we have 2, 1 duplicate. Yeah, it's very simple. So I think there are several ways to solve this question. So let me explain how to solve this question. Okay, so let me explain with this example like 1, 2, 3, 1. And as I told you, there are several ways to solve this question. So one is a sort. So if we sort all elements in input array like a 1, 1, 2, 3, in that case, every time I check the current number and the next number, if they are same, we should return true. Yeah, that solution should be like a n log n time complexity, and memory complexity is I think we don't use extra memory, so order of 1 constant time. And then we can actually improve the n log n time complexity to linear order of n if we use a memory like on. So in that case, we use set. So set is one of the data structures that doesn't allow us to have duplicate values. So in that case, we don't have to sort all elements in input array. We just iterate through from index 0 to last. So now we have one, and then check if we have one in set, but there is no data. So in that case, add one to set, and then move next. We find the two. Check if we have two in set. There is no two, so add two in set, and have a three. So there is no three, so add three into set, and then again we find one, and then we have one in set. So in that case, we have a duplicate. So that's why I return true. And if the last number is 4, in that case, try to find 4 in set, but there is no 4. So in the case, add 4 in set, and then there is no duplicate in input array, so we should return false. So that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, initialize set. So let's say num set, and then start iterating input array for n in nums. And then if n in num set, in that case, return true. If not the case, add current number to set. So num set dot add n. And then if we don't have a duplicate, just return false. Yeah, that's it. So let me submit it. Yeah, looks good. This solution works. I think this question is simple and a very easy question, but I think we can use this idea to other problem. So it's Friday in Japan, so that's why I choose the easy question for today. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of contains duplicate. Step 1, initialize set. Step 2, start iterating, check if current number is in set. Step 3, if yes, return true. If not, add current number to set. Step 4, if you don't find a duplicate in input array, then return false. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel and hit the like button or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question length of last word. So you are given a string S consisting of words and spaces. Return the length of the last word in the string. A word is a maximal substring consisting of non-space characters only. So let's see the example 1. So you are given hello world and the output is 5 because the last word is word is with length 5. So this is an easy case. So tricky case is that, so let's see the example 2. So you may have spaces after the last word, moon. In that case, we have to ignore these spaces. So that's why output is 4. So length of moon. Okay, so let me explain with this example. So you are given hello world, and these red squares are spaces. So you have one space between hello and world. So you have two spaces after a word. And we will use two variables. One is the current index, initialized with the last index. So this includes the spaces. And length variable, and this variable should be return value. And to solve this question, we use two loops. So in the first loop, we find the start point of the last word. Because you may have spaces after the last word. So like this case. So let's begin. So check the current character, and it turns out this is a space. So in the case, we move to like a previous number, and then reduce current index. Again, we check the current character, and it turns out this is a space. So reduce current index to a previous number, and then move next. And then finally, we find the D. This is not space, so that means this is a start point. In that case, we finish the first loop and going to a second loop. So in the second loop, every time we find a character except spaces, we reduce the current index and then add a +1 to length variable. So let's begin. So we find D, it's not space. So in that case, add +1 to length 1, and then reduce the current index to 9. So we move to index 9. Again, we find L, so it's not space. So add +1 to length variable, and then reduce current index to 8. So move index 8. Again, we find R. So in the case, add +1 to length, and then reduce the current index to 7. So move index 7. Again, we find the O. So add +1 to length, and then reduce the current index to 6. So move index 6. So we find the W. So again, add +1 to length, and then reduce the current index to 5. And then now we find the space. In that case, we stop the second loop and then just return length variable, which is 5. And the last word, world. So length of world is 5. So yeah, looks good. So that is a basic idea to solve this question. And with that being said, let's jump into the code. Okay, so let's write the code. First of all, initialize current index and length. And the current index is initialized with last index. So length -1, and length is initialized with 0. And start first looping. So in the first looping, as I explained earlier, you may have spaces after the last word. So we need to find the start point of the last word. So while current character equal space, in that case, add -1 to current index, so minus equal 1. After that, we start second looping. In the second looping, while current index is greater than or equal 0, and current index is not space, in that case, add +1 to length, +1, and add -1 to index. And then after that, just return length. Yeah, actually that's it. So let me submit it. Yeah, this solution works. And the time complexity of this solution should be order of n, because potentially I have to iterate through all characters like one by one. And the space complexity is O1 because we don't use like an extra data structure. So that's why time space complexity is order of 1 constant time. And actually there is another solution for this question. So let me show you how. Actually, we can solve this question with one line. So how can we do that? So just check the length of the last word. So return length and s.split, and take the last word, so -1. Yeah, actually that's it. So for this program, so s.split creates a list like hello and world. And we take the last word with -1 here, and then just return the length of the last word here. So actually that's it. So let me submit it. Okay, so this solution also works, but I'm not sure this solution works for real interview. Actually, in my opinion, this solution a little bit cheating. So you need to ask the interviewer about that. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of length of last word. Step 1, initialize index with 0 and the length with the last index number. Step 2, start the first looping. If your current character is a space, then add -1 to index. Step 3, start the second looping. If index is greater than or equal to 0 and a current character is not space, then add +1 to length and add -1 to index. Yeah, actually that's it. So I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, can place flowers. So you have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. So you are given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and integer n return if n new flowers can be planted in the flower bed without violating the non-adjacent flowers rule. So let's see the example. So you are given flower bed like 1, 0, 0, 0, 1, and you need to plant only one flower. And the output is true because if when we now index 2, so current plot is 0, and so important rule is that flower cannot be planted in adjacent plots. So at least we have 3 0 and the current plot and the left and the right also 0. In this case, when we add the index 2, so current plot is 0 and the left plot and the right plot is also 0. In that case, we can plant flower at index 2 here 1. So that's why we should return true in this case. Okay, so let me explain with this example. So look at the first array. I copied this array from example 1. So basically I iterate through all plots like one by one. And every time I check current plot and the right plot and the left plot. And all 3 plots are empty, which is 0. In that case, we can plant new flower at current index. So let's begin. First of all, at index 0. So flower is already planted, so we cannot plant new flower at index 0. So move next. So check the current plot, it's empty, looks good. And the right side also empty, looks good. But on the left side, flower was already planted. In that case, it's a violation adjacent rules. So in that case, we cannot plant new flower at index 1. So let's move next index. And the current index is empty, current plot is empty, and the right side also empty, and the left side also empty. So in that case, we can plant new flower at current index. So we change to 1. So yeah, that's why we should return true. But let's continue here. So move next and check the current plot. It's empty, looks good. But both sides were not empty. In that case, we cannot plant new flower here. And the last index, so current plot is already planted. So in that case, we cannot plant a new flower here. But we successfully plant new flower at index 2. So that's why we should return true. Very straightforward. And look at the second example. So this is a edge case. What if there are open only index 0 and index 1, and the rest of plots are not empty. So in that case, so first of all, okay, look at the index 1. Index 1, it's empty, looks good, and the left side, it's empty, looks good. But how about the right side? So it's not empty. In that case, we cannot plant new flower index 1. And so let's see the index 0. So current current plot is empty, and the right plot is also empty. And but how about the left side? Actually, there is no left side from index 0. Yeah, it's obvious. In that case, we don't have to care about the left side. We only care about the right side. And in that case, current plot is 0 and the right plot is 0. So that's why we can plant new flower at index 0. And there is no violation because at index 0 and index 2 are not adjacent position. So that's why in this case we should return true. And look at the last example. Actually, it's same idea, just change side from like a left to right. So look at the index 0, 1, 2, 3. Current plot is empty, but left plot is not empty. In that case, we cannot plant a new flower here. And then at the last index, current plot is empty, and the left side is also empty, but there is no right side. But we don't have to care about the right side because this position is a last index of flower bed. So we only care about only left side in this case, and the left side is empty, so we can plant new flower at last index 1. And then there's no violation because last index and the index 2 is not adjacent position. So in this case also we should return true. Yeah, so that is a basic idea to solve this question. With that being said, let's jump into the code. Okay, so let's write the code. We don't have to initialize any variable. So start looping for taking index in range, length of flower bed. And then first of all, check left position. So left equal. So we need two conditions. First condition is current index equals 0. In that case, left position always true because left position of index 0 is a position we don't have to care about. So that means always true, as I explained earlier. And or flower bed current position -1 equal 0. In that case, left position is true. So for right position, so also we need two conditions. So first condition is current position equal the last position. So flower bed -1. So current index is last index. In that case, right position of the last index is a position we don't have to care about, as I explained earlier. So that means always true. Or flower bed current position +1 equals 0. In that case, right position is true. So if left position and the right position are true, and the current position is 0, so in that case, we can plant a new flower at current index. So flower bed current index equal 1, and then count down the number of new flowers. So n minus equal 1. After that, just return n is less than or equal 0. In that case, we successfully plant new flowers, at least the number of n, number of new flowers. So in that case, we should return true. If not, return false. Yeah, that's it. So let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n because I iterate through all plots in the flower bed one by one. And the space complexity is actually O1 constant time because I don't use extra data structure. We just update the flower bed here and count down number of flowers here to keep track of how many flowers we plant. Yeah, so that's why space complexity is constant time, order of 1. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of can place flowers. Step 1, start looping for left plot. If current index is 0 or index minus 1 is 0, then true. For a right plot, if current index is the last index or index plus 1 is 0, then true. Step 2, if the left plot and the right plot are true and the current plot is 0, then update the current plot with 1 and add minus 1 to the number of new flowers. Step 3, if the number of new flowers is less than or equal to 0, then return true. If not, return false. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, find all numbers disappeared in array. So you are given array nums of n integers where ni is in the range from 1 to n. Return array of all integers in the range from 1 to n that do not appear in nums. So let's see the example. So you are given 4, 3, 2, 7, 8, 2, 3, 1. And in this case, n is 8. So from 1 to 8. So output is 5, 6 because 5, 6 do not appear in the range from 1 to 8 in this case. So that's why output is 5, 6. And actually, we have like a follow-up. And could you do it without extra space and in ON runtime? So you may assume that the returned list do not count as an extra space. Okay, so let me explain with this example. To solve this question, I use 2 loops. And in the first loop, I use each number to calculate the index number with this formula. So let's say we have like 4, and the index number is, I put 4 into bar, so 4 minus 1 and index 3. And then go to like a 0, 1, 2, 3. And if index 3 is positive, then multiply minus 1 and change to negative number. So in this case, so 7 is a positive. So we change the 7 to minus 7. And then move next. Again, we use 3 to calculate the index number. So 3 minus 1 is 2. So 0, 1, 2. And if the number at index 2 is positive, then change to negative by like a multiply minus 1. So in that case, we change negative 2. And then move next. So now index 2 is a negative 2. So that's why every time we get the absolute value because we need the index number, but basically index number is positive, not negative. So like this case, the number already negative, like this case. So that's why we need to get the absolute value to calculate the index number. So in this case, the value already negative, but if we get the absolute value, so that means 2 minus 1 is 1. So check index 1. So the number at index 1 is now positive, so multiply negative 1 and then minus 3. So move next. Again, index 1, 2, 3 is already negative, but we don't have to care about that because we always get the absolute value. So minus 7, so absolute value of minus 7 is 7, and the 7 minus 1 is 6. So 0, 1, 2, 3, 4, 5, 6. So 6, index 6 is positive number, so multiply my negative 1 and then so minus 3. And then next, so 8. So 8 minus 1 is index 7. So 0, 1, 2, 3, 4, 5, 6, 7. And then multiply negative 1 and minus 1. And then move next. 2 minus 1. So index 1. So check the index 1, but the number is already negative, so we don't do anything. And then next, so the number is already negative, but absolute value of negative 3 is 3, 3 minus 1, and the index 2, so 0, 1, 2, and at index 2, the number is already negative, so we don't do anything. And then move next, minus 1, so absolute value is 1, minus 1, so index 0. So check the index 0, and the 4 is a positive, so multiply negative 1. So we get a negative 4. Yeah, and so this is a first loop. In the first loop, we change a lot of numbers to a negative number, like minus 4, minus 3, minus 2, minus 7. And that means we could access the index number in the first loop. On the other hand, there are a few positive values. So index 0, 1, 2, 3, 4, index 4 and 5. So which means we couldn't access the index number. So that this number must be a missing number in the range. So we need to convert index number to real number. So how can we do that? So it's simple, index plus 1, because index number usually start from 0. So let's say 0, 1, 2, 3, 4. So index 4. So index 4 plus 1 is 5. So 5 is one of a missing number in the range. And index 5, so 5 plus 1 is 6. So 6 also one of a missing number in the range. And when do we need this calculation? It's simple. So current value is greater than 0. So because if we find a positive number, that means we couldn't access the index number in the first loop. So that must be a missing number. So yeah, that's why we should return 5 and 6 in this case. So that is a basic idea to solve this question. With that being said, let's jump into the code. Okay, so let's write the code. As I explained earlier, we use two loops, and in the first loop, I calculate the index number with each value, and then the number at the index is greater than 0. In that case, we change the value to a negative number. So for I in range and the length of input array, and then calculate index number, so abs, and the current number minus 1. And then if the number at the index is greater than 0, in that case, I change the number to negative number, so index asterisk equal negative 1. So this is a first loop, and I create a result variable with empty array. So this is a return variable, so it is not counted as like an extra space. So in the second loop, so in the first loop, I convert real number to index number. So in the second loop, I convert index number to a real number if the value is greater than 0. So for I in range and the length of input array, and then if current number is greater than 0, in that case, we don't have that index number, so that should be one of the answers. So less dot append, less dot append, and convert index number to real number, so I plus 1. Yeah, actually that's it. So after that, just return result variable. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n. And the space complexity, so follow-up description said this variable is not counted as an extra space. So that's why we don't use an extra space. Yeah, looks good. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of find all numbers disappeared in array. Step 1. Start the first loop, calculate index with each value, and convert the number at the index to negative number. Step 2. Start the second loop. If the value is greater than 0, which means we don't have the index number, so convert it to a real number with index plus 1. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, majority element. So you are given array nums of size n, return the majority element. The majority element is an element that appears more than n divided 2 times, which means more than half of input array. And you may assume that the majority element always exists in the array. So let's see the example. So you are given 3, 2, 3, and output is 3 because we have 2, 3, and 1, 2. So that's why 3 is a majority element. And let's see the example 2. So you are given 2, 2, 1, 1, 1, 2, 2. The output is 2 because we have 4, 2, and 3, 1. So that's why output is 2. It's very simple question. And we have follow-up question. So could you solve the problem in a linear time and in O1 space? Yeah, actually I came up with the 2 solution, but first solution is linear time, but order of n, so linear space complexity. And the second question is linear runtime and O1 space. So I'll show you how to solve this question with 2 ways. Okay, so let me explain with this example. I copied this input array from example 2. So you may come up with a hash map solution, and basically I iterate through all values like one by one. And every time I put each value into hash map and then compare the number of current value with current majority. And then if the number of current value is greater than current majority, then update the majority with the number of current value, and then also update the result variable with current number, like a 2 or 1. And let's begin. So first of all, we find 2. I put 2 into hash map, so 2 is now 1. And compare the number of current value, which is 1, versus current majority is 0. So 1 is greater than 0, so update majority to 1. And then update result variable with 2. And then move next. So now we find the 2 again, so update hash map 2. And then compare the number of current value with current majority, and 2 versus 1, so update majority number 2, and then result variable is now 2, so it's same. And then move next. So we find 1, so I put 1 into hash map, and then this is the first one, so 1, 1, and then compare this number with majority number, so 2 versus 1. So 2, so current majority is like greater than 1, so I don't do anything. And then again we find 1, so update hash map. Now we have 2, 1, and then compare majority number, but they are same, so in that case we don't do anything. And then move next. again we find 1. So now we have 3 1 and compare majority number, and now 3 is greater than majority number 2. So update majority number to 3, and then result variable should be current value 1. So change result variable to 1, and then move next. Again we find 2, so update hash map. So now we have 3 2, and then compare majority number 3 versus 3, so they are same, so we don't do anything. And then move next. We find 2, so update hash map. Now we have 4 2, and compare majority number, so 4 versus 3, so 4 is greater than 3, so update majority number to 4, and then also update result variable with current number 2. So now result variable is 2, and then after that we don't find any number here. So then stop looping, and then just return result variable 2. Yeah, this is a simple solution. So with that being said, let's jump into the code.
Okay, so let's write the code. First of all, initialize hash, and result variable equal majority equal 0, and then start looping for n in nums. And first of all, add +1 to current number, and put the number into hash, so hash, and the key is the current number equal 1, add 1 plus hash dot get, and the current key is the current number, and the default value is 0. And then if current number greater than majority, in that case update result variable with current number, and then update majority equal the number of current value, so hash current number. Yeah, actually that's it. So return result variable. So let me submit it. Yeah, looks good. And the time complexity of this solution is order of n, because I iterate through all numbers like 1 by 1. And the space complexity is also order of n. That is a downside of this solution, because we use hash map, so we have to add all numbers into a hash map. So that's why order of n. And description said, so we have a follow-up description. So could you solve the problem in linear time and O1 space? So with this solution, we could meet linear runtime, but not O1, actually ON. So in the next solution, we solve the question with ON runtime and O1 space. So let me explain how to solve this question. Okay, so let me explain with the same example. So basically I iterate through all numbers like 1 by 1. In each iteration, we check two conditions. And the first, if majority number equals 0, in that case, update the result variable with current value. And then if current number equal result variable, in that case, add +1 to majority variable. If not, add -1 to majority variable. So I'll explain detail with iteration. So let's begin. First of all, we find 2. If majority number equals 0, so now 0. In that case, update result variable with current value. So now result variable is 2. And then if current number equal result variable, so 2 equal 2. In that case, add +1 to majority variable. So now we are now here, and it's obvious majority number is 2. So that's why currently result variable is 2. It's obvious. And then move next.
So now we find 2 again. If majority number equals 0, but now 1, so I don't update the result variable. And then if current number 2 equal result variable, so result variable is now 2, 2 equal 2, so that's 2. So in that case, add +1 to majority variable. So majority number is now 2. So now we check this area. And it's obvious. 2 is a majority number in this case. If input array is like a 2 lengths. And then move next. Now we find 1. So check if majority number equals 0, but now 2. So I don't update a result variable. Still 2 is a majority number. And then if current number 1 equal result variable 2, so in this case it's false. In that case, add -1 to majority variable. So now m equal 1. So now we finish check this range, but 2 is still majority number, so that's why our result variable is now 2. Yeah, looks good. So move next. We find 1. So if majority number equals 0, so now 1, so I don't update the result variable, stay 2. And if current number equal result variable, so 1 equal 2, so it's false. In that case, add -1 to majority variable. So now majority variable is 0. Yeah, and we finished check this range. So now we have 2, 2 and 2, 1. Yeah, we don't know which is a majority number, but at least we find 2 first. So majority number should be 2 in this case. So that's why our result variable is 2, 2. It's obvious. And then, so next is actually an interesting point. So now we are here. So we find 1. If majority number equals 0, so now majority number is 0. And then update result variable with current number 1. So now we change the result variable to 1. And then current number equal result variable, so 1 equal 1. In the case, add +1 to majority variable 1. So now we finish check this range. And as I told you, this is an interesting point. So until this point, 2 is a majority number, but we find 1 like a third time. So now we change the majority number from 2 to 1, right? It's obvious. So that's why our result variable is now changed to 1. So which means so every time majority point reach to 0, in that case we change the majority number with current number. So we start from 0 and then like a 1, 2, so hard to see, but 1, 2, 1, 0. So now at the time we reach the 0 in the case, so we start a new majority number. So that's why result variable is now 1. If we find a 2 here, so again 2 is a majority number, so result variable should be 2 in this case, but we find 1. So then move next, and if majority number equals 0 but now 1, so I don't update result variable, stay 1. And if current number 2 equal result variable 1, so 2 equal 1, it's false, then add -1 to majority variable. So now we reach 0 again. So now we finish the checking this range. So yeah, we reached the 0 now. So we finished the considering 1 as a majority number. So from next time, new majority numbers start. So we don't know which number. And then, but so far, until now, so 1 is a majority number in this case. And then move next. So 2, we find 2. So if majority number equals 0, so actually 0 now. And then, so new majority number starts. So update result variable with current number 2. So result variable is now 2, and 2 equal current value equal result variable 2 equal 2. So that's 2, and then add plus 1 to majority number. So update with plus 1, and then there's no number here. So that's why we should return 2. So let's check. So we have 4, 2, and 3, 1. Yeah, so majority number should be 2. So yeah, looks good. Yeah, so that is a basic idea to solve this question. So this solution, so runtime is linear time because I iterate through all numbers like 1 by 1. And then we don't use extra memory, so space complexity is O1. So with that being said, let's jump into the code. So let's write the code. First of all, initialize result variable and the majority variable, initialize with 0. And then start looping. If majority equal 0, in that case, update result variable with current number. And then majority plus equal 1 if current number equal result variable, else if not, add -1. Actually, that's it. So after that, return result variable. Let me submit it. Yeah, looks good. And the space complexity of this solution is O1. So that's why memory usage is really great. So let me summarize the step-by-step algorithm. This is a step-by-step algorithm of majority element, so hash map solution. Step 1, initialize hash map, result, and the majority variables. Step 2, start looping, add +1 to hash map for current value, and if the number of the value is greater than majority, then update the result variable with current value and the majority variable with the number of current value. Yeah, that is a hash map solution. And this is a ON runtime and O1 space solution. Step 1, initialize result and the majority variables. Step 2, start looping. Change result variable if majority is 0. If current value is equal to result variable, then add +1 to the majority variable. If not, add -1 to the majority variable. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel and hit the like button or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, find the pivot index. So you are given array of integers num. Calculate the pivot index of this array. So the pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index right. So if the index is on the left edge of the array, then the left sum is 0 because there are no elements to the left. This also applies to the right edge of the array. So return the leftmost pivot index. If no such index exists, return -1. So let's see the example. So you are given 1, 7, 3, 6, 5, 6. Output is 3 because the pivot index is 3. So 0, 1, 2, 3 here. So let's see the left side. So total number of left numbers is 1 plus 7 plus 3, so total 11. So let's see the right side. The total number of right side is 5 plus 6 and 11. So two totals are same, so that's why in this case pivot index is 3. Okay, so let me explain with this example. So I copy this input array from example 1. So first of all, initialize left sum with 0, and I already calculate the total number of all values. So total is 28. And basically, I iterate through all numbers like one by one. And in each iteration, I calculate the right sum. So how can we calculate the right sum? It's simple. Total minus left sum minus current number. So when we check the example 1, pivot number, pivot index number is not included. So that's why we need to exclude the current number. So, okay, so let's begin. First of all, we find 1. So calculate the right sum. Total 28 minus left sum 0. And the current number is 1. So total 27. So now right sum is 27. After that, compare left sum with right sum. And if they are same, we should return the current index. If not, add current number to left sum. So in this case, they are not same. So add current number to left sum. So now left sum is 1. And then move next. Now pivot index is 1. And then again calculate the right sum, and the total 28 minus left sum is 1 minus current number 7. So right sum should be 20. And compare two numbers like left sum and the right sum, and they are not same. In the case, add current number to left sum. So now left sum is 8. And then move next. So pivot index is now 2. And then again, total 28 minus left sum 8, 20. And the current number is minus 3. So total right sum is 70. So let's check. So right now, right side is like a 6, 5, 6. So total is 6 plus 5, 11 plus 6, 70. So looks good. And on the other hand, left side, 1 plus 7, 8, looks good. And then compare two numbers, like a left sum and the right sum, and 8 versus 70. So they are not same. In that case, add current number 3 to left sum. So left sum now 11. And then move next. So pivot index is now 0, 1, 2, 3. So again, calculate the right sum. Total 28 minus left sum 11. And 17 minus 6. So right sum is now 11. So compare two numbers. Actually, they are same. In that case, return current index. So 3. So that's why pivot index is 3. So let's check. Left side, total number of left side is 1 plus 7, 8, and 3, and 11. On the right side, total number is 5 plus 6 and 11. So yeah, looks good. So that's why we should return index 0, 1, 2, 3. That is a basic idea to solve this question. With that being said, let's get into the code.
Let's write the code. First of all, get the total number of all values. So sum and nums. And then initialize the left sum with 0. So this is the left sum. And start looping for I in range
length of nums. And then, as I explained earlier, so calculate the right sum. So right equal total minus left sum minus and the current number. So this is a right sum. And then if right equal left, in that case return current index. If not the case, add the current number to left sum. So left plus equal nums and then I. Yeah, actually that's it. So if we don't find a pivot index, then return -1. That's it. So let me submit it. Yeah, looks good. And time complexity of this solution should be order of n because I iterate through all numbers like one by one. And the space complexity is actually O1 because I don't use extra data structure, just a variable. Yeah, I think space is constant time. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of find pivot index. Step 1, initialize total of all values and the left sum with 0. Step 2, start looping, calculate a right sum by total minus left sum minus current value. If the right sum is equal to the left sum, then return the current index. If not, add the current value to the left sum. Step 3, return -1 if you didn't find a pivot index. Yeah, actually that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave your comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, longest common prefix. Write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, return an empty string. So let's see the example. So you are given like a flower flow flight, and the output is FL because all three strings has FL in the first two character, like here, here, here. And look at the third character of each string. So flower has O, flow has O, so looks good, but flight has I. In that case, that is not common prefix, so that's why we should return FL. Okay, so let me explain with this example. Yeah, a little bit messy, but I hope you can understand easily. And first of all, we use two variables. One is a prefix and the other is plen. So I initialize prefix with the first string because actually we can pick one of them, but in my opinion, the initialize with first string is I think the easiest way to solve this question. And the plen is a length of prefix, so in that case 6, 1, 2, 3, 4, 5, 6. And these numbers are index of each character. So yeah, I think easy to understand. And then we call flow S1 and the flight S2. And basically I iterate through all character one by one. So let's begin. And the first string is prefix, so we start iteration from index 1, I mean flow. So compare prefix versus S1, and from 0 to plen 6. So flow has length of flow is 4. So in that case, looks like out of bounds, but in Python, we get the flow itself. I think this is a Python way. So if you use other language, be careful. It should be out of bounds. So anyway, in Python, we get the flow itself, and compare prefix flower versus flow. They are not same. In that case, add -1 to plen. So in this case, 5. And then if plen equals 0, in that case we should return empty string, but plen is now 5. In that case, update prefix like from 0 to plen 5. In that case 0, 1, 2, 3, 4, 5, but 5 is not included, so now prefix is this area. And then again check this prefix versus S1 from 0 to 5, but still flow is flow because the length of flow is 4. So compare this prefix versus flow. They are not same. In that case, add -1 to plen 4, and plen is not 0. And update after that update prefix from 0 to 4, 0, 1, 2, 3, 4, but 4 is not included, so now flow. And then again compare flow versus flow, because of 0 to 4, so 0, 1, 2, 3, 4, so flow itself. Actually they are same. In that case, we move next string, because these two strings they have a flow, so that's why common prefix should be flow in this case. So now prefix is a flow, and then move next. And then again, since we already update plen with 4, in that case we should start from 0 to 4, because we have to find like a common prefix, so there's no way like a prefix is more than like 5 characters. So 0 to 4, so 0, 1, 2, 3, 4, but 4 is not included, so compare this area versus flow, and compare two prefix, and they are not same. In that case, again add -1 to plen 3, and then update prefix 0, 1, 2, 3, but 3 is not included, so we update prefix with FLO. And then again compare prefix versus 0 to 3, so in this case here, this area, FLI versus FLO, and they are not same. In that case, add -1 to plen, so 2, and update prefix from 0 to 2. In that case, FL, next range is FL. So again, compare FL versus S2 from 0 to 2. So in the case here, this range, FL versus FL, so actually they are same. In that case, we just move next, but there is no strings here. So we finish the iteration, and then just return current prefix, which is FL. So let's check. Flower has FL, flow has FL here, and then flight has FL. And then look at the third character. Flower has O, flow has O, they are same, but flight has I. So that's why third character is not common prefix. So that's why longest common prefix should be FL. Looks good. So that is the basic idea to solve this question. With that being said, let's get into the code. Okay, so let's write the code. First of all, initialize pref with first string, so 0, and plen equal length of prefix, and then start iterating. S string in strs and start from index 1. And then while prefix is not equal s, and from 0 to plen, in that case, add -1 to plen, minus equal 1. And if plen equals 0, in that case, there is no common prefix, so just return empty string. After that, update prefix, so prefix equal pref from 0 to plen. Actually, that's it. After that, return current prefix. So let me submit it.
Yeah, looks good. And the time complexity of this solution is roughly order of n plus m. N is the length of input array, and m is length of the first string. I think something like that. So let me explain a step-by-step algorithm. This is a step-by-step algorithm of longest common prefix. Step 1, initialize prefix with the first string with length of prefix. Step 2, start looping from index 1 if prefix is not equal to the current string with range from 0 to length of prefix. Then add -1 to length of prefix. If the length is 0, return empty string. If not, update prefix with range from 0 to length of prefix. Step 3, return the current prefix. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, unique length of 3 palindromic subsequences. So you are given a string s, return the number of unique palindromes of length 3 that are subsequence of s. Note that even if there are multiple ways to obtain the same subsequence, it is still only counted once. A palindrome is a string that reads the same words and backwards. So subsequence is, so we have an example. So ACE is a subsequence of ABCDE because ABCDE has all characters like ACE and the same order, so A and C and E. So let's see the example. So you are given A, B, C, A, and the output is 3 because the 3 palindromic subsequence of length 3 are like A, B, A, and A, and A, C, A. So that's why output is 3. Okay, so let me explain with this example. You are given A, B, C, A, D. And I believe this question is much easier than you expected. And first of all, we initialize the 2 variables. One is a result variable with 0. So this is a return value. And a unique character. So in this case, unique character in the string is like A, B, C, D. And we try to find each character from beginning and from last. So let's try to find A. So we find A at index 0 here. And from the last, we find A here. So now we know that we make sure that we can create a 3 palindromic subsequence between if we make this area unique because we already have both sides like A and A same characters. So just make this area unique so that we can get a 3 palindromic subsequence. So to make this area unique, we use like a set. So in this case, so unique character is A, B, C. So there is a 2B. So, but if this area, if we make this area unique, so output is A, B, C. So that's why we can create like A, B, A, C, A. So in that case, we get a 3 unique palindrome subsequence. So update the result variable to 3. And okay, so
let's try find B. From beginning we find here, and from the last we find here. So in that case, try to make this area unique, but it's already unique. So I think easy to understand. So from this area, we can get a unique palindrome, like a one palindrome, so PAB. That's why our output is now 3 plus 1 is 4. And how about C? From beginning, we find the C here. And from the last, we find the C here. And it's same. In that case, we can't create a palindrome string, so we don't update the result variable. And how about D? From beginning, we find D is here. And from the last, we find a D here, and same things. There's no space, so we can't create a palindrome strings, so we don't update the result variable. So that's why in this case, output should be 4. Yeah, that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, initialize the result variable with 0 and get a unique character from string. So unique equals set and s. And start looping for character in unique. And first of all, try to find a unique character from beginning and from the last. So let's call, from the beginning, let's call it start index. So equal s dot find c. So this is a search character from the beginning, and let's call the like an end index. This is from the last, and equal s dot. If we find a specific character from the last, we can use r find and c. So this is like a searcher character from the last index. And after that, if start is less than end, in that case we can create a length 3 palindrome subsequence. So less plus equal and the length of unique characters between start and end. So set and s start plus 1 colon end. So y plus 1, because in Python this number is included. So but we need between start and end. So that's why we need to add plus 1. And then this number is not included. So that's why I just put end here. So after that, just return result variable. Yeah, so let me submit it. Yeah, looks good. And the time complexity of this solution should be order of 26 of n. So 26 is a number of alphabet. Because potentially, so unique, this unique has 26 characters. So that's why this for loop possibly execute like 26 times. And we search the character in the string, so that's why order of 26 of n. And the space complexity is actually same, 26 of n, because this unique variable has potentially 26 characters. So that's why. So let me summarize step-by-step algorithm. Okay, so this is a step-by-step algorithm of unique length 3 palindromic subsequences. Step 1, initialize the result variable and get the unique characters from input string. Step 2, start looping. Find each unique character from the beginning, start index, and the last end index. If start index is less than end index, try to make unique characters between start index and end index and count length of unique characters. So I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave your comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, merge sorted array. So you are given two integer arrays, num1 and num2, sorted in non-decreasing order, and two integer m and n representing the number of elements in num1 and num2 respectively. So merge num1 and num2 into a single array sorted in non-decreasing order. The final sorted array should not be returned by the function, but instead be stored inside the array num1. To accommodate this, num1 has a length of m plus n, where the first m elements denote the element that should be merged, and the last n elements are set to 0 and should be ignored. Num2 has a length of n. So let's see the example. So you are given like num1 is 1, 2, 3, 0, 0, 0, and the m equals 3. So first three elements should be merged, and num2 equal 2, 5, 6, and n equals 3, and the output is 1, 1, 2, 3, 5, 6. So yeah, that's simple. The array we are merging are 1, 2, 3, and 2, 5, 6. The result of merge is 1, 2, 2, 3, 5, 6 with underlined elements coming from num1. Yeah, that's simple. So important constraints are num1 length equal m plus n, and num2 length is n. And we have a follow-up question. Can you come up with an algorithm that runs in m plus n time? So I'll show you how to solve this question. Okay, so let me explain with this example. This is a num1, so 1, 2, 3, 0, 0, 0, 0. And m is an index number for num1. And this is a num2, 2, 5, 6, and n is an index number for num2. And this is a num1. So we will merge two lists into num1. So this is a num1 used for merging two lists. And every time we compare the m number and n number, and then we put the bigger number into num1 from the last, and the last index should be m plus n minus 1, because this is an index number, so we need a minus 1. So let's begin. First of all, we compare 3 versus 6. So 6 is bigger than 3, so we put 6 here. And then in the case, we move n to next. Also, we move last pointer to next. And then again compare 3 with 5, and the 5 is bigger than 3, so I put 5 into last pointer here, 5, and then move next, and then move next, and then compare 3 with 2, and 3 is bigger than 2, so I put 3, no, not n, this is L, and I put 3 into L, last number, last index, so 3, and then m move next, and then L move next, and then in this case they are same, so I put these two into last index. So now last is 2, and then move next, so there is no number, and then last pointer move next, and luckily, so we merge two lists into num1. So actually we can finish the iteration because we have 1 2 already 1 2 here. So this input this num1 is already sorted, like 1 2 2 3 5 6. Even if we have like a list of elements here, we don't have to iterate through all index. So yeah, that is a basic idea to solve this question. Let me explain one more like edge case. So what if this is 4 and this is a 3, this is a 3. In that case, this 4 goes to here. So now compare this 3 with this 2, and the 3 is bigger than 2. So I put this 3 into last index here, 3, and then move next, and then move next. Again, compare 3 with 2, and the 3 is bigger than 2. So I put 3 into last index here, 3, and then move next, and move next. But there is no number here, so we cannot compare two numbers anymore, but we still have one element in num2. So this element should be merged into num1. So after we compare two numbers, if we still have element in num2, we have to iterate through all elements to merge them into num1. So after that, iterate through num2, and then we have to put this 2 into last index here. So now 2, and then move next, and then move next. Then we finish, and the description said final sorted array should not be returned, so we finish. Yeah, that is a basic idea to solve this question. With that being said, let's get into the code. Okay, so let's write the code. First of all, last equal m plus n minus 1, and start looping while m greater than 0 and n greater than 0. In that case, we compare two numbers. So if nums1 and m minus 1, because we need to get like a index number. So greater than nums2 n minus 1. In that case, nums1 last equal nums1 and m minus 1. And then add minus 1 to m minus equal 1. Else nums1 last equal nums2 n minus 1, and add minus 1 to n minus equal 1. And in both cases, we have to add minus 1 to last index, so last minus equal 1. And then, as I explained earlier, if if we still have element in num2, we have to iterate through all element in num2. So while n greater than 0, in that case, nums1 the last equal nums2 n minus 1, and then n minus equal 1, and the last minus equal 1. And we don't have to return any variable or values. So yeah, that's it. So let me submit it. Yeah, looks good. And the time complexity of this solution should be order of m plus n. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of merge sorted array. Step 1, initialize last index with m plus n minus 1. Step 2, start looping, compare two numbers from nums1 and nums2. Then put a bigger number into nums1 at last index. Add minus 1 to m or n that is merged into nums1 at last index. Step 3, after step 2, if we if we still have elements in nums2, then add all rest of the elements in nums2 into nums1. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, jump game 3. So you are given array of non-negative integers array, and you are initially positioned at start index of the array. When you are at index I, you can jump to I plus current value or I minus current value, and check if you can reach to any index with value 0. Notice that you cannot jump outside of the array at any time. So let's see the example. So you are given 4, 2, 3, 0, 3, 1, 2, and the start position is 5, 0, 1, 2, 3, 4, 5 here. And goal is index 0, 1, 2, 3. So this example should be true because there are two ways to reach to index 3. So first of all, index 5, and we can go like index 6 or index 4. And in this case, in the first case, we go to index 4 here. And then after that, we can go like move or jump forward or jump back again. But jump forward, we will be out of bounds. So we jump back like 1, 2, 3, index 1, and then we can again jump forward or jump back. And then if we jump back, that is like out of bounds. So we jump forward 1, 2, and then we reach the index 3 here. So that's why output is true. And in the second question, yeah, it's almost same. And then we can reach like index 3. Okay, so let me explain with this example. Like 4, 2, 3, 0, 3, 1, 2, and the start is 5, index 5. And actually, I solved the jump game and jump game 2 with dynamic programming. So at first, when I read this question, I thought we can solve this question with dynamic programming, but it turns out I realized that okay, so if now we are index 2, we can jump forward or back 3 times. So 1, 2, 3, and then we have to jump again, like jump forward or jump back. So it works like a tree traversal. So so that's why I think this problem we can solve this problem with like a breadth first search or depth first search. And from now on, so I explain solution with breadth first search. So let's begin. So this is an input array, and this is a start point, and we prepare for like a visited with set, because there are two cases we have to finish the program and return false. So one is out of bounds, and the second we come back the same place, because let's think about like 2, 0, 2, and start from 0. So in that case, we can jump like a move forward or move back, but move back is out of bounds. So we have to move jump forward. So 1, 2, and then we have to jump forward or jump back again. But if we jump forward, we are out of bounds. So we have to jump back 1, 2, and then again we have to jump forward or jump back, but jump back is out of bounds, and we have to jump forward like 1, 2. This is a kind of a like an infinity loop. So, but we have to finish the program. So that's why we have to store like the place we already visited. First of all, I forgot initialize Q, and now Q has index 5. So let's begin, and first of all, I pop value from Q, in this case 5, and then add index 5 to visited 5, and check the index 5. There 1, 2, 3, 4, 5, 5. So we can jump forward once or jump back once, and both sides are not out of bounds. So add both index to Q, in this case 6 and 4, 6 and 4, and then again I pop the value from Q, in this case 4, and then add 4 to visited, and check index 4, 0, 1, 2, 3, 4, and we find 3. So we can jump forward 3 times, 1, 2, 3, and it's out of bounds. So we cannot jump forward or jump back 3 times, 1, 2, 3, and we reach the index 1. So in that case, add index 1 to Q and 1, and then again pop the value from Q, in this case 1, and add index 1 to visited, so 1, and check the index 1. So we can jump forward twice or jump back twice, and in this case if we jump back twice, it's out of bounds, and jump forward 1, 2, and then add current index to Q, in this case 0, 1, 2, 3, 3, and then again pop the last value from Q, 3 in this case, and then yeah, I didn't check any values, but every time we pop the index from Q, of course we check the current value, and then if current value is 0, we should return true. So in this case finally we found the 0 value in this case, so that's why we should return true. So that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, initialize Q with start index and visited, initialized with set, and start looping while Q. First of all, if Q has data, I pop the last value from Q, and index equal Q dot pop, and I use current value a lot, so I put current value to jump variable, so array and current index, and then first of all, if jump equal 0, in that case we found the 0 value, so return true, and if current index not in visited, in that case we are now at new place, so add current place to visited, so visited add current index, and if current index plus jump, that means jump forward is less than length of input array, in that case add next index to Q, so Q, and this is a list, so I think append, and I plus jump, and if I minus jump, that means jump back is greater than or equal 0, in that case add next index to Q, so Q append I minus jump, and yeah, actually that's it. After that, return false. So if we find a 0 value, we can return here. So if we finish this iteration, that means we didn't find the zero value, so that's why we should return false. So let me submit it. Looks good. And the time complexity of this solution should be order of n, because we visited each place once, because we have visited. And space complexity also order of n, so potentially I have to put all place into visited. So this is a best first search solution, and okay, I'll show you depth first search solution. Okay, so first of all, initialize visited with set, and I create an inner function, depth first search, and taking index. And first of all, check the base case. If current index is greater than or equal length of input array, or current index is less than 0, or current index in visited, in the case return false. And if current value equal 0, in the case return true. After that, add current place to visited, so add I, and then check the next index. So left get not check, get the left next index. So left is left point is like a current index minus current value, and the right equal current place plus current value, and then check the call the depth first search again, and left case, or DFS, and the right case. So if we find the 0 in one of them, then return true. If not, return false. And after that, return depth first search with start point. I think that's it. So let me submit it. Yeah, looks good. And if we can optimize the space complexity, we don't have to use set visited if we can change the input array. So I'll show you how. Okay, so modification is not big deal. So we remove this visited, and so okay, we have to change here. So in this case, if we can change the input array, so let's say, so current value equal, let's say -1, in that case return false. So in that case we remove this visited, and so we are this program, we calculate the next index. So after this, after calculation for next index, so update current value with -1. I think this works. So let me submit it. Yeah, looks good. And yeah, we can successfully improve the memory usage. I think previous depth first search should be like 8% or something. Now 27. So we can apply the same logic to breadth first search, I think. And but I'm not sure we can change the input array or not. So you need to discuss the like a modification with interviewer. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of Jump Game 3. Step 1, initialize Q variable with start index and a visited variable with set to prevent you from visiting the same index. Step 2, start looping. Pop the last value from Q variable, and if the current value is 0, then return true. If not, check if the current index is a new place. If yes, add the current index to visited variable. And check next indices where we can reach with jump forward and jump back. If the next indices are not out of bounds, then add them to Q. Step 3, return false if you finish looping in step 2. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, Pascal's triangle. So you are given integer num rows, return the first num rows of Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it as shown. So let's see the example. You are given num rows equal 5 and the output is like this. Actually this picture. So in the first row, you can see 1 because there's no number on the left side and the right side, because this is the first row, so we don't do anything. And look at the second row. So from this position, there is no number on the left side, but you can see the 1 on the right side, so that's why this position is 1. And the same thing, from this position, you can see the 1 on the left side, but there is no number on the right side, so that's why this position is also 1. And look at the third row, and from this position, so there is no number on the left side, but you can see the 1 on the right side, so that's why this position is 1. And look at this position, center of third row, and now you can see the 1 on the left side, and you can also see the 1 on the right side. So that's why total number should be 2 here. And then from this position, and you can see the left, you can see the 1 on the left side, and there is no number on the right side. So that's why this position should be 1. Yeah, and we do the same thing. And then in the end, we can get this Pascal's triangle. This question is actually very simple. So okay, let's look at the fourth row, and fourth row has like 1 3 3 1, because from this position you can see the 1 on the right side, but there's no number on the left side, so that's why this position is 1. And from this position, 1 plus 2 and 3. From this position, 2 plus 1 equals 3. And then from this position, 1 plus, there's no value here, so that's why this position is 1. And I think these three position, from these three position, it's easy because you can see the numbers on the left side and the right side. But how can we how can we calculate on the edge of both sides? So because there is no numbers here and there is no number here, so how? So I think a simplest way is just add 0 here and here. So when we calculate each position in the fourth row, add 0 to the head of third row and end of third row, so that we can avoid out of bounds or something, unexpected error. So 0 means nothing. So That's why if it's equal to there is no number here, and so that's why in this case 0 plus 1 and 1, and then 1 plus 2 and 3, and 2 plus 1 and 3, and then 1 plus 0 and 3 1. So I think this 0 makes the program easier for us. So that is our basic idea to solve this question. With that being said, let's get into the code. Okay, so let's write the code. First of all, initialize result variable with like a 2D array and 1. And start looping for underscore in range and num rows minus 1. And first of all, create a row with 00. So let's call it like a dummy row equal 0 plus result minus 1 plus 0. So this result minus 1 is the row right above current row. So if you are in the second row, this means like a first row, and add 00 to head and end, and then initialize row with empty list, and we need another for loop for I in range, and length of result minus 1, because we have to add numbers, and but we need a plus 1 to reach the end of 0, this one. And then after that, row dot append, and calculation is very easy, just a dummy row and I plus dummy row I plus 1. And then after that, just add row to result variable, so res dot append and a row. Yeah, actually that's it. After that, just return result variable. Yeah, so let me submit it. Looks good, and the time complexity of this solution should be order of n squares, because we iterate through all rows, and which is n, and we have another for loop to iterate through all numbers in a row, so which is n. So n multiply n, which is on square. And space complexity is also order of n squares, because we have a 2D array. Yeah, so let me summarize step-by-step algorithm. This is a step-by-step algorithm of Pascal's triangle. Step 1, initialize 2D array with 1. Step 2, start looping, create a dummy row with adding 2 zeros, as the numbers on the left and the right. Step 3, return 2D array. Yeah, I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, non-decreasing array. So you are given array nums with n integers. Your task is to check if it could become non-decreasing by modifying at most one element. We define the array is non-decreasing if current value is less than or equal next value. Hold for every I such that the I range is like greater than or equal 0 to n minus 2. So let's see the example. So you are given 4, 2, 3, and the output is 2, because if we modify this first 4 to 1, so we can create like a non-decreasing array, 1, 2, 3. So that's why output is 2. And let's see the example 2. So you are given 4, 2, 1, and the output is false, because we have to modify twice to create a non-decreasing array, like between 4 and 2 and between 2 and 1. Okay, so let me explain with these three examples and look at the first example. So basically, we iterate through all numbers like one by one, and every time we check the like adjacent number, and we start from index 1 because we want to check the like a current index minus 1. So in this case, looks good, and between 2 and 2, they are same, looks good. And between 2 and 4 looks good. And then now we find like a violation. So, but we can modify the number once. So this is this is good. And then check the next numbers, and then 2 and 5 looks good. So in this case, it's simple, just return true, right? And look at the second example. Actually, this is an interesting point. And again, start from index 1, and 3 and 4 looks good, and move next, and 2 and 4, it's a violation. And but this is the first time, so looks good. And then move next, and 3 and 2, and this is a non-decreasing relationship, so looks good. So that, and in this case, it looks like true, but look at the look at the 4 when we are like a last index. So 3 is smaller than less than 4. So between 2 and 3 looks good, but look between like a 4 and 3, 3 is smaller than less than 4. In this case, it's a violation. So that's why in second case, we should return false. Basically, so we don't have to modify any numbers, because this is like a Boolean question, like a return true or false. But there is some case where we have to modify the number to return the correct answer. So in this case, we find a violation between 4 and 2. So when we find the violation, we have to check if current number is less than current index minus 2 number, which is 3 in this case, and y minus 2. So let's look at the third example. So we start from index 1, and 3, 4, and looks good so far until 4, and we find the violation when we reach the 2. So we know that we make sure that until 4, these numbers are non-decreasing order. That means index 3 is definitely greater than index 2. So when we find a violation here, check the non-adjacent number, precisely current index minus 2. And if current number is less than current index minus 2, which is 3, so we should update this current number to with a current index minus 1, so that definitely current number is greater than like a previous like a number like this, like 1, 2, 3. because also in these three, 3 is definitely biggest number. So we can make sure this number is greater than or equal like between from index 0 to 1 to 3, index 3. So that's why update this number. So now update 2 with this number, so 4, and then check the next number, and 5 and 4, so non-decreasing relationship looks good. So that's why in this case return true. So look at the second case again. So if we don't modify any number, so as I told you, these two relationship is like a non-decreasing order, so that looks like a true case. But so between 4 and 3, it's like a decreasing order, so which is a violation. So to prevent the violation, when we reach the index 2, so look at the non-adjacent number, so current index minus 2, and compare two numbers. So 2 is less than 3. In that case, update current number with current index minus 1, which is 4. So 4 in this case. And then, so now the range between index 0 to 2, index 2 looks good, like 3, 4, 4 looks good. And then move next. So we find 3, but the relationship 4 and 3 is like a decreasing relationship. In that case, we find a violation twice. That means we should return false in this case. Yeah, so that is a basic idea to solve this question. So with that being said, let's get into the code. So let's write the code. Actually, it's not difficult. So first of all, we should have like a flag, change flag. So, and start looping for I in range. So we start from index 1. So 1 to length of input array. After that, if current number is less than adjacent number, so I minus 1. In that case, we need to modify the number definitely. So first of all, but if we already changed before, in that case, this time we modify twice. So that means we should return false. And then if not the case, change flag to like a true. And as I explained earlier, if index number is greater than or equal to, and yes, so this is a this check is like out of bounds or not. And then current index, current number is less than I minus 2. So we check the adjacent number here, and so this time we check the non-adjacent number, which is a current index minus 2. In that case, update current number with the number at index minus 1, as I explained earlier. And then after that, return true in this case. Looks good. And the time complexity of this solution should be order of log n, linear time. And we don't have an extra data structure, just a variable. So I think space complexity is O1. Let me summarize step-by-step algorithm. This is a step-by-step algorithm of non-decreasing array. Step 1, initialize changed flag with false. Step 2, start looping if a current number is less than previous number, current index minus 1. Then, if we already changed the number once, then return false. Step 2, change the flag to true. Step 3, current index is greater than or equal to, and the current number is less than a number at current index minus 2. Then update a current number with previous number, so current number in the current index minus 1. Then after that, just return true. Yeah, actually that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel, hit the like button, or leave a comment if you have any question. So I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question, rotate image. So you are given M by M 2D matrix representing an image, rotate the image by 90 degrees clockwise. So you have to rotate the image in place, which means you have to modify the input 2D matrix directly. Do not allocate another 2D matrix and do the rotation. Let's see the example. So you are given like 1, 2, 3, 4, 5, 6, 7, 8, 9. And we have to rotate this image like a clockwise, like this, and like this. So in the end, output should be like a 741, 852, 963 in this case. Yeah, very simple question, and looks like everyone tried to solve this question. So we should do the solve this question. And I think there are many ways to solve this question. And yeah, I came up with a few solutions, but I'll show you I think I believe the easiest way to solve this question. Okay, so let me explain with this example 1, 2, 3, 4, 5, 6, 7, 8, 9. And we try to rotate this image 90 degrees clockwise. So first of all, imagine you have a line here, and then swap the number in the same column. So that means 1 and 7, and 2 and 8 and 3 and 9. We swap the numbers. So in that case, the image like 7, 8, 9, and 4, 5, 6, and 1, 2, 3, right? After that, okay, draw so imagine the diagonal line like this from like a top left to like a bottom right, like this diagonal line, and then swap 8 and 4 and 1 and 9 and 2 and 6, 2 and 6. So after that, image should be like a 7, 4, and 1, and this 8 should go to this. So 8, 5, and this 6 will go to this position. So and 2 will go to this position. So 2 and 9 is here, and then 6 and 3. And actually this is a answer. return value. So let's check. So initial image is this one, and rotated 90 degrees clockwise is like this. So if we rotate 1 to 90 degree clockwise, this one should go to here, right? And 1, and 2 should be go to here, and 2, and 3 should go to here, and 3, and 4 should go to here, and 4, and 5 doesn't move, right? And 6 should go to here, and 6, and 7 should go to here, and 7, and 8 should go to here, 8, and 9 goes to this position here. Looks good. So I think there is a pattern, moving pattern. So you can, I think you can manage one by one. But I think this lines make question easier, I think. That is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, edge length equal length of matrix. And first of all, swap the number between top numbers and the bottom number. So top equal 0 and the bottom equal edge length minus 1. And start looping while top is less than bottom. So in the case for column in range, edge length. So first of all, draw a center line and then swap the numbers. So first of all, keep the top top row value to temp variable. So matrix and top and the column. After that, update this position to same column but bottom, right? And then after that, update this position and to with temporary variable, right? So I think we successfully swap the numbers. After that, update top plus equal 1 and bottom minus equal 1. So after that, draw a line diagonally and then swap the numbers. And it's hard to put a name for variables. So let's say I equals 0 and while I is less than edge length, and for j in range, and start from I plus 1 to edge length. So y plus 1. So position should be 0 0 and 0 1 0 2, and this is 1 0 1 1 1 2 and 2 2 2, right? And now we draw a line like a 0 0 1 1 2 2, right? And swap the number 0 1 and 1 0 0 2 2 0 and 1 2 2 1, right? So that's why we have to iterate through like a 0, 1, only 0, 1, 0, 2, 1, 2, right? So if when I is 0, I mean I should be actually low position here. This is a I position, and J is like a low column position. So when I is 0, so we iterate this row, and we don't have to check 0, 0. So that's why we start from 0, 1. So that's why we need plus 1, and 0, 1, 0, 2. And then when I is 1, in that case we don't have to check 1, 0, 1, 1. We can start from like a 1, 2 in this case. So that's why this position is 1, 2, and when I is 1, we start from like a 2 for J. So 1 plus 1 is 2, right? And then when I is 2, so J should start from like here, but this is out of bounds, so maybe this loop not executed. So then finish looping. So that's why we need to like a plus 1. Yeah, if you don't understand my explanation, so please let me know in the comment below. So in that case, actually we do the same thing, like a temp equal matrix and I and J, and then update this position to actually we swap I and J, I, right? Let's say 0, 1, and swap the index number like 1, 0, and for 0, 2, we have to swap this number, so 0, 2, 2, 0. So that's why we swap the like IJ, JI, yeah, and update JI to temporary variable. Yeah, I think we can swap this number with these 3 lines, and then after that add plus 1 to I plus equal 1. Yeah, after that just return matrix. Yeah, let me submit it. Yeah, looks good and very efficient algorithm. So time complexity of this solution should be for like swapping the like a top and the bottom numbers algorithm. So that should be like an order of column multiply row divide 2, half length of row, and plus, and for like swapping the number like diagonally, so that should be like an order of row multiply column divide 2, roughly I think this time complexity. So yeah, little bit complicated, but I think roughly this time complexity for this algorithm. And space complexity is actually we don't use extra data structure, just update input matrix. So if we don't count this matrix, I think O1 space complexity. Yeah, so let me summarize step-by-step algorithm. This is a step-by-step algorithm of rotate image. Step 1, imagine you have a horizontal line at the center of the image. Swap the numbers between top and the bottom. Step 2, imagine you have a diagonal line from top left to bottom right. Swap the numbers between the diagonal numbers. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel, hit the like button. or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the LeetCode question spiral matrix. So you are given m by n matrix, return all elements of matrix in spiral order. So let's see the example. So you are given 1, 2, 3, 4, 5, 6, 7, 8, 9. Output should be 1, 2, 3, 6, 9, 8, 7, 4, 5. So we have to iterate through like a spiral order like this. So, yeah, a very simple question. So let me explain how to solve this question. Okay, so let me explain with this example. And so I initialize many variables. So x and y is like a current position. So dx and dy is like if dx1 and dy 0, that means we go to right direction because this is index 0, 1, 2, and 0, 1, 2. So every time we add dx to x, so dy to y. So in that case, every time, in this case, we add 1 to x, so that means move right, and y is still 0 because 0 plus 0 is 0. So in that case, we go right position. So let's begin. First of all, we are standing 0, 0. And yeah, we already visit this position. And then after that, if next position is not out of bounds, we just add dx to x and dy to y. So in that case, next position should be 1, 0. So now we move this position and we find 2, so we visit this again. Next position is not out of bounds, so just add 2 and 0. So we move next position and we visit this position. And then if we go to right direction, that is out of bounds. In that case, we change the direction with this formula. So update dx with minus dy and update dy with dx. So now dx is 1. So dy should be 1. And dx is a minus dy. So we update dx and dy at the same time. In that case, dy was is a 0, so dx should be 0. So in this case, every time we add +1 to y position and we add 0 to x position, in that case, we going down like this. So until now, we move right, and next we go down this direction, right? Because 0, y is like a vertical direction. So if we add 1 to y, definitely we go down the next row position. So in that case, next position should be 2, 1, and then we reach this position, and then next position should be not out of bounds, so add 1, so 2, 2, so we go down this position, and then next position should be out of bounds. In that case, we use this formula and update x, dx, dy at the same time. And current dx is 0, so next dy should be 0. And for next dx, update minus dy, so dy is now 1, so next dx should be minus 1. And I delete this. So next, we go to left position, left direction. So that's why dx should be minus 1, like x is like a column or like a horizontally. So dx should be like this direction, and we don't move like a y position. So yeah, definitely we can go to left direction. And so now 2 2 and add -1 to x, so that should be 1 1 2, and dy is 0, so x is 1 and y is 2, so definitely we can go this position. And then next position is not out of bounds, so add -1 to x, so 0, and add 0 to y, and c2, so 0 2 0 2, and we reach this position. And then next position should be out of bounds, so update dx dy at the same time, and current dx is -1, so dy should be -1, and the current dy is 0, so next dx should be 0. So definitely we can move like upper side. So next position, add 0 to x and add -1 to y, so next position should be 0 1, so x is 0 and y is 1, so here definitely we can go to this position. And so next position is not out of bounds, but we already visited this position. In that case, it's same as like out of bounds. So we change the direction with this algorithm formula, and current dx is 0, so next dy should be 0, and current dy is -1, so next dx should be -1 multiplied -1, so that should be 1, and I delete this. So now we move on 1 for x direction and 0 for y position. So add 1 to x, so x should be 1, so add 0 to y, so y is 1, so still 1. So next we move 1 1, so 1 1, and then we reach 5. Then we successfully iterate through all position in like a spiral order like this. That is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, get the length of row and the columns. So rows and the columns equal length of matrix and the length of matrix 0. And I have to initialize many variables like x, y, and the direction x and the direction y. So initialize 0, 0, 1, 0, and the result variable with empty list, and start looping for underscore in range, and we have to visit all places, so rows multiply calls, and first of all keep current value to result variable, so less dot append and the matrix y and x, and we have to update current value with any specific for example characters, so that we can prevent like revisiting. So matrix y and x equal, so I update current value with like a period. So you can put any character like a hash or asterisk, whatever, but I put a period to prevent revisiting. And check if out of bounds or not. So if not, 0 greater than or equal x plus dy dx less than close or not 0, greater than or equal y plus dy and less than rows, or matrix y plus dy and x plus dx equal period. That means we already visited that place. In that case, we have to change direction. So as I explained earlier, update dx and dy at the same time. So dx and dy equal minus dy and dx. So in Python, we can write a code in a line. And after that, update current position. So x plus equal dx and y plus equal dy. Yeah, that's it. After that, just return result variable. Yeah, that's it. Let me submit it. Yeah, looks good. And time complexity of this solution should be order of m by n because we have to visit all places in the matrix. And space complexity also, I think, order of m multiply n because we have to keep all values into a result variable. Yeah, that's why time and the space are both like an order of m by n. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of spiral matrix. Step 1, initialize length of rows and columns, x, y, dx, dy, and result variables. Step 2, start looping, add a current value to result variable and update it with a character to prevent you from revisiting the same place. Step 3, if next position is out of bounds, and change direction with dx, dy equal minus dy and dx. Then update current position. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, today we are going to solve the leetcode question missing number. So you are given array nums containing n distinct numbers in the range 0 to n. Return the only number in the range that is missing from the array. So let's see the example. So you are given 3, 0, 1, and the output is 2 because so for this input array, so range should be 0 to 3. So we have 0, 1, 3. So 2 is a missing number, obviously. So that's why we should return 2 in this case. Okay, so let me explain with this example 3, 0, 1. And so value range should be from 0 to 3. And the missing number should be 2 in this case. And yeah, actually there are a lot of ways to solve this question, but the most simple and efficient way is like to get differences between like in total index numbers and total values. So let me write down the index number 0, 1, 2. And basically we iterate through all numbers one by one. And for each values, we use index number because these index number goes through the all numbers from 0 to 2 in this case. So that means result plus equal index number minus this input array should be nums and the current value. And so every time we calculate this simple formula. So let's begin. So first of all, index is 0 minus current number is 3, so result should be minus 3. And move next. Index number is 1, and minus current number is 0, plus 1, so result should be minus 2. And index number is 2, minus 1, and so plus 1, so minus 1. And yeah, finally we get minus 1. But as I told you in this example, so 2 is a missing number, but we get minus 1. So why we get a minus 1? Because we forgot to add the last number in the range from like 0 to 3. So index number usually start from 0 to minus 1, length minus 1. So we forgot to add the last number in the range, because this value range should be 0 to 3, but we just add like a 0, 1, 2. So we need to add plus 3 in this case. So we get the minus 1, and we need to add plus 3, and that should be 2. So yeah, we successfully get a missing number 2. Yeah, that is a basic idea to solve this question. So with that being said, let's get into the code. Okay, so let's write the code. First of all, initialize result variable with 0, and start looping for index I in range and length of nums. And as I explained earlier, so we use index number, so result plus equal index number minus current number to get the differences. And then at last, we need to add the last number in the range, so result plus equal length of nums. And then after that, just return result variable. Yeah. So to make the code short, so actually we can initialize result variable with length of num, and then we remove this program. I think this is more like a simple. So let me submit it. Yeah, looks good. And the time complexity of this solution should be order of n, linear time, because we iterate through all numbers like one by one. And space complexity, actually we don't use extra data structure, so I think a constant time or 1. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of missing number. Step 1, initialize result variable with length of input array. Step 2, start looping, add current index minus current number to get the differences between total number of the range and the total number of the range except missing number. Yeah, that's it. I hope this video helps you understand this question well. If you like it, please subscribe to the channel, hit the like button, or leave a comment. I'll see you in the next question. Hi everyone, before I solve the question today, so thank you for watching my video. So finally I got 160 subscribers. So I remember at the end of November, I reached the 100 subscribers. So since then, just 4 months, I got 60 new subscribers. Yeah, it was actually unexpected because for the first 2 months, I got 0 subscribers. So it was a tough journey, but finally I got 60 subscribers in a month. So yeah, I'm very happy, and I will continue to upload a new video in the next year. So please subscribe to the channel and hit the like button or leave a comment. So let's get started. So today's questions is case largest element in an array. So you are given an integer array nums, and the integer k returns the case largest element in the array. So very simple question, and then note that it is a case largest element in the sort order not case distinct element. So you must solve it in ON time complexity. So let's see the example. So you are given 3, 2, 1, 5, 6, 4, and the k is 2. So output is 5 because we need to find the second largest number in input array. So that should be 5 in this case. So that's why output is 5. Yeah, very simple question. But point is we have to solve this question with a linear time complexity. So I think simplest way is to sort them out and then choose the second largest number. But I think that is like a quick sort or merge sort. That is like a order of n log n time complexity. So yeah, but we have to solve this question on linear time. So let me explain how to solve this question. Okay, so let me explain with this example, 3, 2, 1, 5, 6, 4, and the k equal 2. So we need to find the second largest number in input array. So to solve this question, we use quick select, which is very similar to very famous sort algorithm, quick sort. So if you don't know how quick sort works, actually I created a video a few months ago. So I put the link in the description below, so check it out. For quick select, we use a left pointer and a right pointer. So for left pointer is most left index of the range. So initially, so 0. And the right pointer is the most right index of the range. In this case, 0, 1, 2, 3, 4, 5, 5. And we use a pivot and index number and pointer. So pointer is updated with left pointer, so that's why initialized with 0. And the pivot is initialized with right pointer, so that's why pivot is last index. So basically, we iterate through all numbers one by one. So that is an index number, current index number. And every time we check current value versus pivot, and if current number is less than or equal to pivot, in that case we will swap the number with current number versus this pointer number. So let's begin. So first of all, pivot number is 4 versus current number is 3. So current number is less than pivot. In that case, we swap the number, but p also pointing to 3, so we don't change anything. And then after that, if we swap the number, we move this p pointer to next. And also next current index number is 1. So next 4 versus 2. So current number is less than pivot number. So in that case, we swap the number, but it's same. So we don't do anything, just update a p number to next. And next. So in this case, again, current number is less than 4, and swap the p number and the current index number, but they are same, so we don't do anything. Just update the p number to next. And the next index is 3. So value is 5 and 4. So current number is greater than or equal greater than pivot number. So in that case, we don't swap anything, and we don't move this p pointer to next. So just move index I here, and then check the current number versus pivot, and the current number is greater than pivot. So in that case, we don't do anything. And then so we reach the pivot, so we stop iteration. So now p pointer is pointing index 0, 1, 2, 3. And pivot number is 4. And at last, we have to swap 5 p value and pivot value. So that means this index value is 4 and the last value is 5. So the reason why we swap the number is, so look at the this area versus this area. This area. Oops. So before p, all numbers in the area is less than pivot p number, and in the orange area, so all numbers are greater than pivot number. So now we can successfully separate like a smaller number and a bigger number. Okay, so look at the k number, k equal 2, and where the second largest number is located. So actually we can calculate with k number. So that is length of input array minus k. So that is length of input should be 1, 2, 3, 4, 5, 6. 6 minus 2 is 4. So at least the second largest number is located at index 4 or above. So why above? Because this input array is still not sorted, actually unsorted input arrays. So that's why we don't know where is the second largest number, but at least second largest number is located at index 4 or above. So that means we can find the second largest number in orange area because 0, 1, 2, 3, 4. Right? So if k equals 3, so we need to, if we need to find the third largest number in input array, in this case, length minus k equals 3. So in that case, we have a 2 larger number, and then on the left side of p pointer, so all numbers are small. So that means this p number is a third largest number. In that case, we can immediately return the like a p index, right? But now k is 2. So we know that at least second largest number is located in orange, somewhere in orange area. So after that, we call the quick select again, but this time, so we so first of all, we pass like a left pointer with 0 and the right pointer equal 5, but we focus on only orange area this time, so left pointer should be 4 and the last index number should be 5. Okay, so next we focus on the only orange area. So now left pointer is 4 and the right pointer is 5. So pivot number still the last index 5, update with right pointer, and this is a current index, and this p pointer is updated with left pointer, which is 4 here. Then start looping. So compare current number with pivot number. So current number is greater than pivot number. In that case, we don't do anything. But at last, we swap the current p value and the pivot number. So now 5 is index 4 and 6 is the last value. So same thing, look at the this area. Oops, look at the look at this area. So so we have a 2 number and 6 is greater than 5. So in that case, 6 is the biggest number in the array. So that means so this p number is now the second largest number in input array. So check p is length minus k. So p is greater than length minus k, which is 4. We have to search on the left side, and if p is less than this 4, in that case, we have to search the target number on the right side. And actually, if p is the same as this number 4, actually that's true. In that case, that is a target number, so we should return 5 in this case. Okay, so let's write the code. First of all, calculate the actual target index number. So k equal length of input array minus k, and return quick select, passing the left pointer and the right pointer, so nums minus 1. And let's create a quick select function. So def quick select, and left and right, and pivot and p pointer, so updated with nums and right and left. So start looping for I in range from left to right. And if nums, so current number is less than or equal pivot, in that case swap the p and I equal, so we swap these numbers, so I and p. After that, move p to next, so plus equal 1. And after we reach the end of input array, so after that we swap the current p number and nums right, so which means that this is a pivot number, equal, and this is a right, so and p, so that we can separate like a small number and larger numbers, and this k numbers. So after that, if p is greater than k, in that case, so target number definitely on the left side. So in that case, return quick select, and the same left pointer and the right pointer should be p minus 1, because we have to search on the right side, left side. And else if p is greater than less than k, in that case k is definitely on the right side of p, so return quick select, and small number should be, so left pointer should be p plus 1 and the same right number. And else, so as I explained earlier, actually current p is pointing the target number, so just return nums p. Yeah, actually that's it. So let me submit it. Yeah, looks good, but it's not good efficient, because so quick select is average time complexity should be linear time order of n, but in some case, so for example, we continue to pick the largest number or smallest number as a pivot number. In that case, so time complexity should be O(n) square or something. So yeah, in some case, very bad time complexity. So next, let me modify this program so that we can, I think, improve the runtime. Okay, so to improve the runtime, so we have two choices. One is so now we fix the pivot number as like a last number right here. So we change the like a random pivot so that we can improve the runtime. So another thing is that we should shuffle this input array before we start quick select. So I take that algorithm. So in that case, before start quick select, so for I in range, and so yeah, we can do several ways, but simplest way is start from the last. So length of input array minus 1 and -1 and -1, and then j equal random dot rand int start from 0 to index I. So yeah, that's why we start from the last. So it's easy to decide the last value, and after that nums I and nums j. So we swap the two numbers here. So equal this number should be j, this number should be I. So I think this is a O(n) solution. So I think that's good. And so let me submit it. Yeah, so we can improve the runtime drastically. The previous one is like a 90% or something. So now we get 64%. Yeah, so let me know if you can improve more. So let me summarize step-by-step algorithm. This is a step-by-step algorithm of case largest element in array. Step 1, calculate the target index. Step 2, shuffle input array to avoid the worst case. Step 3, start quick select. Step 1, set pivot and p pointer. Step 2, if the number is less than or equal to pivot, then swap current p number and current number and move p pointer to next. Step 3, swap the p number and the pivot number so that we can separate numbers into smaller, larger, and pivot. And step 4, if p is greater than k, so k is a target index in step 1. So the target number is on the left side. If p is less than k, in that case, target number is on the right side. So step 5, if not the case, the number pointed by p pointer is the target number. Yeah, actually that's it. I hope this video helps you understand this question well. If you like it, please subscribe the channel, hit the like button, or leave a comment. I'll see you in the next question.